All right, well, I talked about the shader graph last time, and let me show you a kind of analogous feature, the visual effect graph. There's documentation down here and a rather comprehensive tutorial based on Unity 2.18, but it works just as well. So the idea behind the visual effect graph, it complements the built-in particle system. The old Shuriken system that makes nice particle effects. But in these scriptable render pipelines, there's another, the visual effect graph. One key point of VFX is that it simulates its particles on the GPU instead of on the CPU. This is the built-in system particles are processed there. And for this reason, it's able to simulate many more particles without having much of an effect on your frame rate. It is a package and as such must be installed either with the universal render pipeline or with the high definition one. I believe that in universal it's still considered a preview, although that may have changed. It is certified for the high definition render pipeline. Now what we'll see is that its user interface is very similar to the shader graph in that it has a kind of modular connect by wires program flow environment. Same way with the shader graph, we connect the boxes together by wires. We do the same thing in shader graph. Starting with the very simplest effect, kind of the default, the one that you get when you create a VFX. Now there are a couple of ways to do this, but basically what we want to build is a VFX asset template. And there are a couple of ways to do this. In our project, we can come down here and find, that's not what I wanted. We can come down here and find visual effects and visual effect graph. And this has now made a new VFX asset. And I'll just leave the default name there. Now I've got the, I have the graph window docked here. And if I click on this, it opens up this sort of flow graph of the of this asset. Now we don't yet have a game object, and there are basically two different ways that we can make a game object. We can go over here, and we can come down and select. No, I'm sorry. We can go up here and we can select a visual effect. This makes an object that has the visual effect component on it. And this is where we put the VFX, the shader graph asset. So I drag this over into this slot. And right away we have our particle system going and doing this. Alternatively, let me delete that. I can just take this and drop it into the scene, and it creates an object, new VFX, that has that template established on it, and it's ready to go. So two different approaches. And we can rather quickly change what the particle effect is here by dropping a different asset template in here. Just very quickly to show you that, let's see, my VFX graph. Here's the ribbon particle. And so right away, this now becomes a completely different object with different uh, behavior. Let me put this back in. So that's how to get things started. Now, the basic template that we've seen there that you get when you just create one raw has all the pieces that you need for a particle system. Like the shader graph, the VFX graph is a flow diagram, and its system is composed of four basic units called contexts in a vertical workflow. We're going to talk about the horizontal workflow in a little bit. And the four basic contexts are spawn, initialize, update, and output. There are other outputs besides quad, but the quad is the one that we're most familiar with from the built-in particle system. Now, the contexts themselves contain blocks that define the behavior of that specific context. And you can reorder them and move them around, but they basically stay within their blocks. The blocks themselves have properties. And these properties are editable fields that can accept input from a horizontal workflow. So over on the left here, we're going to have stuff flowing in to the various exposed properties in the individual blocks. The horizontal workflow is going to include exposed inspector variables, things that show on the inspector of the particle system. And these input variables can be modified with various operators, things like mathematic operations, add, multiply, and so forth. Now, the main contexts are the spawn context right here. And let me show you navigation here. First of all, you can always press A, and that kind of tries to put the whole thing on screen. You can do the Alt key and drag things around, and you can focus on one of them and press F, and it will zoom in on that one. So here in the spawn, I have a block called constant spawn rate, and here's that exposed editable rate, which I can attach horizontal workflow to. The next one is the initialize, which defines the particle when it's born. Things like how many particles you can have in the system. This one is limited to 32 particles. There's the bound, which is the volume of space in which the particle will execute if it's visible in the camera. And here we have two blocks, set velocity random and set lifetime random. Update is how the particles behave over time. And right now the update here is empty. There's no block in it. So nothing is going to happen here. And finally, there's the output, which is how the particle is rendered. And in the output block, we have the particle that's going to be rendered. This is the little default particle, which is kind of clock. And we have how the particles are oriented and set size over lifetime. This is going to use a curve, and set color over a lifetime. This is going to use a gradient. And these are just the default values. You can change things, things like changing how the orients the particles. You can start to see some of the similarities between these and the various modules of the built-in particle system. The built-in particle system has that whole first module that is the initial conditions of the particle. But then we go down and we have the spawn and the shape and all the other things, color over time and over lifetime and stuff like that. So it's a different layout, a different way of thinking about particles, but it is somewhat different. So enough. Let's look at one of the basic some of the provided templates, and the one that we see here. And let me back out here, and I'm going to sweep this thing and delete it. And I'm going to open up. I'm going to create a node, and this is where one makes all of the different boxes. But here in the system are a bunch of default templates, an empty particle system, heads and sparks, heads and tails, and so forth. And I'm going to open this simple particle system, which is exactly what we got when we started it to begin with. So this contains a spawn context with a constant spawn rate block. It's emitting 16 particles per second. It has an initialized content with that capacity of 32 with the set velocity random. And notice here we have these vectors. This is basically blowing things in the x direction between minus 0.33 and plus 0.33, in the vertical direction by 0.2 to 1, and in the z direction by minus 0.33 to 0.3. So this is making a cone that's blowing up in the air. And we have a set random lifetime between 1 and 3 seconds. The update context, as I mentioned, is empty, and the output quad context has a slot for the particle, texture, and an orient, a set size over life, and a set color over life. Now, within the context, we can create a block. And so here in the update particle one, you can see there it says press space to add a block, or you can right click and create a block. And it is now a content sensitive menu of different things that you can add to the update function. You'll get different menus depending which of the contexts you're working on here. So I'm going to, I could drill down through force and find gravity, but the easy way to find gravity is to just type it here in the search window, and here's the gravity force. And now my particles are falling with minus 9.8. Let me make that minus 1. And now they're kind of spraying up, maybe 0.5. And now they're spraying up in the air and falling down. So very easy to generate this. I can add a texture here. So in the output one, instead of this default particle, which is nice for kind of setting things up, but is not the kind of particle that you would use. Somewhere here I have a more standard particle, default. Here's the default particle. Notice one is default particle, all one word, and this is default dash particle. And so now right away, my particle system is making particles that look a lot more like particles. They're not little clocks. Other templates include that heads and spark. So one can add those other templates here. I think I have a scene with the head and sparks. I'll save that. So here's the head and sparks. Here's heads and tails. Here's ribbons. Let me play ribbons so you can see it. So there's the ribbons. And here's a really interesting one, the swarm. The swarm, which is an interesting one in that it's really stress testing a lot of particles. Notice my frame rate here. I have VSync turned off, but I've got 50,000 particles, and it's showing no real slowdown, no real lag with this many particles. I've modified this one in something called lots of particles. And I want to show you a little bit about what I've got here. Hierarchy, lots of particles. So the lots of particles, uh, uh, the lots of particles graph has a bit of this horizontal workflow. Here's our vertical workflow, but here's horizontal workflow, whose goal is to deposit something in the rate here. It's going to deposit something in the rate. I've also got a little workflow down here. I've also got a little workflow down here in that I have a color over lifetime exposed variable. Now, the place that this all comes in is with another component of this, which is called the blackboard. And this is the same blackboard that we saw in the shader graph. It's input variables that are shown in the inspector. So I have color over lifetime, minimum rate, maximum rate, and speed. And so if I look at my lots of particles object, here are the properties of this lots of particles asset template. I've got the color over lifetime, minimum, maximum, and speed. Now, it has these little check marks, which let you override the defaults. Here's the default gradient for color over lifetime. If I check this, then I can go in here and pick some other gradient and override it. But if this is not checked, it goes back to the default that is here. So my minimum rate is by default 0. My maximum rate is by default 25,000, but with this check mark, I've overridden it to 200,000. And the speed, which is going to be how fast it goes from the minimum rate to the maximum rate, is 0.1. And I got it overridden, but it doesn't matter. So let's look at that horizontal workflow. We have a total time, this first node here, which I got by clicking on the black workspace and creating a node and finding the time, the total time node. And this is just basically the time.time that we use in script all over the place. I've got speed, and incidentally, the way one gets these into the world is by dragging and dropping them here. So there's the speed that I could then hook up to whatever was appropriate. Let me delete that. So up here in my horizontal workflow, let me close the blackboard. I've got the total time and that speed variable, and I'm connecting that to a multiply. So I'm going to multiply time by speed. I then take that maximum rate, 25,000 or whatever, and I'm going to multiply it by the result of that calculation. Then I'm going to add the result to the minimum rate. So this is going to be minimum rate plus speed times time times maximum rate. In order to keep this from exceeding the maximum rate, which is would as the time progresses, I'm going to feed both of these into this minimum float. Uh, it's the minimum of the maximum rate and my current calculated rate. And when I'm all done with that, I assign that to rate. And my particle effect now starts off kind of slow, and the rate at which particles are generated is increasing constantly with time. And, uh, and I'm ending up here with close to 400,000 particles, and my frame rate is still a completely respectable 45 to 50. So pretty cool, pretty cool. The little script there called particle count that displays in my UI element how many particles I've got in the system. Um, um, First of all, if we want to access the visual effect, we need to include a Unity engine.vfx, similar to .ui, in order to have UI elements like text. And I'm updating this in a coroutine updater that basically loops around, waiting a certain number of seconds and querying the effect, which has been dropped into this public variable, public exposed variable here. The effect dot alive particle count converted to a string is being displayed in my particle window. So that's all very cool. I'll show you one other thing. And in the package manager for the VFX, in the package manager for the VFX, it has this import into project visual effect additions. It doesn't work in the universal render pipeline, at least not with some futzing. But it does work in the high definition pipeline. And so here's the high definition pipeline that has a bonfire, it has flames, it has lightning, it has smoke and sparks. And it's worth looking at some of these. You remember with the shuriken, we had a particle system, and we combined particle systems together to make particle effects. So we had things like more than one particle system kind of layered on top of each other. We had births and deaths that were spawning sub-emitters. Well, you can do the same thing in here. So I actually have several different vertical workflows that are different particle systems here. I believe one of them is, well, let's look at the bonfire. In the bonfire, first of all, I've got a bit of horizontal workflow as this thing goes across, but I have three vertical workflows. These are subgraphs. These are subgraphs that do different particle effects. So it's worth having a look at these, but I will warn you that they don't seem to work in the universal pipeline. Flames here is just one vertical. Bonfire, I believe, is a combination of flames, smoke, and spark. That's why it's a bit more complicated. And just to show you that this, of course, works, here's a little scene, the high definition render scene. There's sparks over here. I seem to have broken the flames because they're not triggering. I don't know what I did to it, but I apparently broke it. Up here in the sky is lightning going on. So I assure you the bonfire does work. I just broke something when I was in it. But anyway, I'm going to stop there. I'm going to stop sharing. And I'll stop the recording and I'll see you all in class. Bye.